geometry from the scanned object. Very quickly, let's extract this plane, which is at the bottom. As you normally see, you're probably worried what this is a constraint about. Well, the software automatically finds the best fit of this plane and it creates it as it approximates in the best way all the points of the scan. The problem is that sometimes they are not really accurate, and the goal, or what we call design intent, is actually to create this plane in the best way for the design, which in our case means, I will just show the coordinate system, that technically what I want is this to be parallel to the bottom. So that's why we use here, and we can choose that this plane needs to be parallel. What we introduce in our version is something what is called auto constraint. This will help the user when extracts some primitives automatically to generate this primitive in the best possible way. Let's explore what the parameters means. This plane exists in space, but it can be a little bit tilted and not aligned to any specific plane. So this will control when the created primitive will be actually constrained to some of the other primitives, in this case, to be parallel to the bottom. So if this plane is actually tilted less than 0.5 degrees, the software will assume that we want this to be horizontal, and it automatically will create this parallel. I will create this. I will take this plane here and will create another one. Now, as you see, the software found this plane and it discovered that the tilt angle is less than 0.5 degrees with the bottom plane, and it's automatically created this plane. To understand why this is important, we will do some analysis on this plane. As you can see now, everything is in blue and red because the scan surface here is not what we want. Of course, we can remove the constraint, and you see that the fit plane approximates the scan data very well, but it's not actually parallel to the bottom. So that's why it's quite useful to use this auto constraint option to make sure that all these planes are parallel. In this way, I'm really confident now that this is more manufacturable. Let's explore some other options. I will just pick this cylinder and we'll create the cylinder. The software will try again to auto constrain this. What happened in this case is the software found that based on the tilt tolerance means the axis of the cylinder is almost as the z-axis. So it will create this parallelism. It will create this cylinder to be parallel to my z-axis. But there is also another option here, which is called coincidence tolerance. What this means is that it will take the point from the axis of the cylinder and it will find that it's actually close with less than 1 millimeter to the z-axis, to the blue arrow which you see on the screen. And in this case, we'll create it completely coincidence with the z-axis, which is actually what we want to do. And now we'll create. We'll carry on and create another cylinder here to demonstrate again. As you see, the cylinder now it's again concentric with the z-axis, and this will ensure that both cylinders are completely in line. So this is how quickly you can extract the primitives in a more accurate way. You can always go back and edit them, but with this option, auto constraint, you can create much more accurate models that are with their design intent. I hope this video is useful. Thank you for watching.